Imagine a 7 billion-year-old visitor from beyond our solar system, drifting silently through the galaxy, finally waking as it nears the Sun. Will it survive the intense solar heat, or will humanity witness its final moments live in the sky? In just 65 days, the ancient interstellar comet 3I Atlas will make its closest approach, offering a once-in-a-lifetime opportunity to observe a cosmic time capsule billions of years old. Comet 3I Atlas was first spotted by the Atlas Survey System at the Rio Hurtado Observatory in Chile on July 6, 2025, and later confirmed on July 25. Unlike ordinary comets that orbit our Sun, 3I Atlas is hyperbolic, moving fast enough to leave the solar system forever after its brief visit. Its journey through the Milky Way spans billions of years, long before Earth or the Sun existed, making it possibly the oldest object ever observed by humans. Even now, as it approaches perihelion, it releases massive amounts of ice and dust, creating a glowing spectacle that challenges our understanding of cometary physics. The story of 3I Atlas is also a story of human curiosity, perseverance, and collaboration across the globe. On August 29, 2025, Vamshi Casaretti, an amateur astronomer in California, spotted a faint object at magnitude 17, over 600 times fainter than the human eye can perceive. Within hours, a network of amateur astronomers from every continent formed a continuous 24-hour observation chain, capturing hundreds of 60-second exposures daily. Over 61 consecutive days, this network created the clearest, most continuous time-lapse of an interstellar visitor ever recorded, surpassing the capabilities of any professional observatory. One of the most baffling phenomena recorded was the comet's tail reversal. Initially pointing toward the Sun, the tail gradually flipped, defying the laws of physics that dictate solar radiation should push dust away. Scientists discovered that the comet ejected unusually large dust particles, up to 0.1 millimeters, 1,000 times bigger than those in typical comets, causing delayed reactions to solar forces. Dr. Teddy Krita of the LOL Observatory described it as a transition never before so clearly documented in a decade of cometary studies, marking a milestone in modern astronomy. Chemical analysis of 3I Atlas revealed anomalies that stunned researchers worldwide. The James Webb Space Telescope recorded a CO2-to-water ratio of 8.1, 26 times higher than the solar system average, with carbon dioxide outgassing at 129 kilograms per second, while water evaporated at only 6.6 kilograms per second. This extreme imbalance suggests that CO2 ice is not just a surface layer, but a deep, primordial component of the comet, possibly formed in a carbon-rich environment or altered by billions of years of cosmic radiation. Every molecule released is effectively a message from the early universe, a glimpse into chemistry that predates our planet. Even more puzzling, atomic nickel was detected without any iron, an anomaly that defies conventional stellar chemistry. Normally, nickel and iron are produced together in supernova explosions, yet here, the nickel emission increased fivefold over a few weeks, while cyanide levels rose in parallel. Scientists propose unusual condensation in the comet's birth environment, or the sublimation of iron over billions of years as possible explanations. Regardless, this unprecedented chemical signature remains a mystery, forcing astronomers to reconsider the complexity of interstellar matter. Researchers are divided on how 3I Atlas survived for billions of years while developing its extreme composition. One theory, the cosmic radiation hypothesis, suggests that high-energy rays broke down water and carbon monoxide, recombining into carbon dioxide and forming a protective crust over the comet. Another theory proposes an exotic formation environment where the comet formed in a carbon-rich red dwarf system, allowing CO2 ice to condense directly, with surface tholins produced by radiation over billions of years. It is likely that both mechanisms contributed, creating a comet unlike any previously observed in our galaxy. As the comet approaches perihelion, thermal stress intensifies at 0.8 astronomical units from the Sun, increasing the chances of fragmentation or explosion. Solar radiation will nearly double, heating sealed gas pockets and potentially triggering violent surface eruptions. Scientists predict 4 possible outcomes: a smooth pass, partial fragmentation, exposing the interior, surface explosions, or total disintegration. Each scenario carries invaluable scientific data, offering rare insights into the structure, composition, and resilience of interstellar matter. Observation campaigns for 3I Atlas are unprecedented in scale and precision. The International Asteroid Warning Network launched a 60-day monitoring program from November 27 to January 27, coordinating NASA's Deep Space Network, Hubble, James Webb, Gemini South, and 2 global amateur networks totaling 250,000 observers. Professional telescopes provide high-resolution images and detailed spectra, while amateurs offer 24-hour real-time monitoring, impossible for even the largest observatories. Together, this human and technological network ensures that no moment of 3I Atlas's approach will go unrecorded. Amateur astronomers have become heroes of this story, proving that scientific discovery is no longer limited to professionals. Teachers, engineers, students, and retirees observed night after night, capturing every nuance of the comet's behavior. On August 29th, after 61 days of continuous observation, the global network announced, "We did it. We caught an interstellar visitor." This collaborative achievement demonstrates that science is a human endeavor, open to anyone willing to look up and dedicate time to exploration. To put the significance of 3I Atlas into perspective, we look at previous interstellar visitors. Oumuamua in 2017 was elongated, tailless, and accelerated anomalously, defying expectations. Borisov in 2019 resembled a typical comet, but fragmented in 2020, while 3I Atlas is extraordinary with its extreme CO2 content, nickel without iron, and ancient age. Each interstellar object is a chemical and physical time capsule, carrying secrets from distant star systems across billions of years of galactic travel. Some scientists have even speculated whether 3I Atlas could be artificial. Dr. Avi, a Harvard astrophysicist, suggested that its size and unusual composition might indicate alien technology, though Hubble observations show the comet is smaller than initially estimated. While mainstream science favors natural explanations, the comet's extreme anomalies challenge conventional thinking. Whether natural or artificial, 3I Atlas inspires humanity to ask bolder questions about matter, life, and the history of our galaxy. The final 65 days before perihelion are critical, with every telescope and observer focused on the comet. Peak activity is expected between December 25th and January 5th, after which brightness will gradually decline. Scientists monitor torque caused by rotation, gas pressure buildup, outgassing rates, and potential fragmentation events. Humanity is watching with bated breath, ready to witness either survival or destruction of this ancient interstellar traveler. 3I Atlas is not just a comet, it is a window into the earliest history of the galaxy. Its dust and gas carry vital information about star formation, chemical evolution, and processes that predate the Sun. Survival over billions of years, despite cosmic rays, gravitational disturbances, and interstellar collisions, shows the resilience of matter across time. Observing this comet allows humans to witness events that occurred long before life existed on Earth, in real time. If you want to follow this story as it unfolds, subscribe and turn on notifications to Cosmic Voyager. Comment below with your thoughts. Will 3I Atlas survive perihelion, or will it fragment and reveal its primordial interior? This is a once-in-a-lifetime opportunity to see a 7-billion-year-old comet awaken before our eyes. Over the next 65 days, every observation, spectrum, and image will bring us closer to understanding the oldest secrets of our galaxy. The countdown has begun, and amateur astronomers remain vigilant, recording every frame nightly. Professional telescopes like JWST, Hubble, and Gemini South provide crisp data, but only a global network of humans can capture the comet's continuous evolution. Whether it survives or breaks apart, 3I Atlas represents a cosmic chemistry experiment billions of years in the making. Humanity stands witness to a story unfolding across the sky, and the next 65 days may reveal secrets older than the Earth itself. As perihelion approaches, scientists are divided on what will happen. Thermal stress may cause surface explosions, exposing the CO2-rich interior or even fragmenting the comet entirely. If the nucleus remains intact, it will offer the maximum possible data on the structure and chemical composition of an interstellar object. Every scenario promises insight into cosmic processes that have shaped the galaxy for billions of years. The comet's tail, now stretching 7 times the length of Earth, glows with a blue-gray gradient caused by large dust grains near the nucleus and fine particles swept away by solar radiation. Each twist and flare of the tail reveals details about the size, velocity, and composition of its dust particles. Amateur astronomers stitched together thousands of exposures to produce a continuous record that even professional observatories could not achieve. This level of detail allows scientists to study changes in real time, tracking the comet's awakening with unprecedented precision. Chemical anomalies continue to astound researchers, with CO2 dominating over water by an extreme ratio and nickel appearing without iron. Cyanide levels rise alongside nickel emissions, presenting a phenomenon that defies standard cometry models. Some scientists propose that these chemical signatures reflect the comet's formation in an exotic star system, while others argue for billions of years of radiation processing. Regardless, 3I Atlas challenges every assumption about interstellar chemistry and the durability of matter over cosmic timescales. The collaborative effort of amateurs and professionals is unmatched in human history. Observatories in Chile, Japan, Germany, Australia, and Canada work alongside tens of thousands of individuals, sharing data and coordinating through real-time alerts. This network ensures that every tail reversal, outgassing event, and dust flare is recorded continuously. For the first time, humanity witnesses the evolution of an interstellar object in real time, unbroken by day-night cycles or geographic limitations. Even as questions about alien technology persist, the natural explanations are extraordinary enough. Cosmic radiation, exotic formation environments, and unique particle sizes all combine to produce a comet unlike any other. Its survival across billions of years of collisions, gravitational perturbations, and interstellar hazards is miraculous in itself. Scientists emphasize patience, waiting for final perihelion observations before drawing any conclusions, highlighting the evolving nature of scientific discovery. The final approach of 3I Atlas will reveal either a smooth survival, partial fragmentation, violent surface eruptions, or total disintegration. Each outcome will teach humanity something new about interstellar physics, cometary structure, and the chemistry of the early universe. This single comet may provide more insight into galactic history than decades of routine observations. Millions of eyes, both human and technological, are fixed on the same faint point of light, eager for the revelation. 3I Atlas is not merely a cosmic object. It is a narrative of survival, time, and human endeavor. Its billions of years of existence, resistance to destruction, and chemical oddities present an unprecedented opportunity to study the universe's infancy. Amateur astronomers, armed with small telescopes, have contributed data surpassing that of professional observatories alone. Humanity is witnessing a story written over billions of years, now unfolding in the present, and every moment may hold answers to the oldest questions about our galaxy. This is the story of 3I Atlas, a 7-billion-year-old interstellar traveler awakening after eons of dormancy. Its tail flips, dust and gas streams, and chemical signals provide an intricate cosmic narrative. Every observation, from amateur and professional sources alike, contributes to a deeper understanding of interstellar matter. The next 65 days will determine whether this ancient visitor survives perihelion or fragments, but either outcome will be a historic event that reshapes our understanding of the universe.